I'm Anil Kumar, sharing with you few questions based on marking the region where many conditions are satisfied. The question here is, construct a triangle ABC in which AB equals to 5 centimeters, angle BAC equals to 45 degrees, and angle ABC is 60 degrees. Construct also the perpendicular bisector of AB and a circle, center C, radius 4 centimeters. If a point moves inside ABC so that PC is less than 4 centimeter and PA is less than PB, shade the region in which P must lie. Now, before solving this question, let me take a few other questions where we'll discuss marking regions and then we'll get back to this particular question. I hope that will help us to understand things better. And so let's take up a simpler question first, where we will only shade the region and then we'll take a simpler question with half the conditions and then we'll get back to this. So that is going to be my approach. In this video, we will understand how to find a region which satisfies given conditions. So I've taken relatively simple examples. We'll work with square and circle. We're not going to do much construction here, but we are going to use properties of square and circle to answer or reason out our solution. So we have two questions. Let's go through them one by one. The first one is, X is a point which moves inside the square. Right, that's the first statement. That means it could be anywhere inside, right? That is what it means, inside the square, correct? So this is my first step. X is a point which moves inside the square, PQRS. Now the second condition is that XS is greater than XQ. That means these points, one of these points, which are possible solution, is for the condition XS is greater than, that means the points which are closer to Q rather than X, right? So if I join these 2 points, diagonals, then we are looking for this portion. We are looking for this portion. That is what it means when I say XS is greater than QS. So all these points are farther away from S as compared to Q. Correct? Now let's look into the next condition, which is XR is greater than XP. XR is greater than XP. That means it is farther away from R. So let me join this line. Why am I using dotted lines? Because it is greater than, not equal to. So that means it has to be somewhere in this portion. Do you see that? Somewhere in this portion. Now the question is, indicate clearly the region in which X must lie. So what is common to all we did so far? That is the solution. You get an idea, right? So that is how we will be defining our regions. So that will be this region. Do you see that? So that is how we are going to provide the solution. And of course, the center point is not a part of our solution. So I'm putting a big hole there. It is not a part of our solution. Since we are talking about greater than, not equal to. So is that clear, right? So that is how we are going to do it. Second question here is, a circle ABCD of radius A. So basically, we have this circle whose radius is A, right? So let's say, so that means the length is 2A here for the square. Okay. Is inscribed in a square PQRS. Indicate clearly the region in which the point X must lie within the square PQRS if Cx is greater than equal to. So see, equal to means you have to include the line also. So CX is greater than AX. So CX, so any point CX is greater than AX. That means it is closer to this side, right? So what I will do here is divide it like this. I could have done with the solid lines. Let me do it solid line this time, because it is greater than equal to, right? So the point is that CX is greater. So it is on this side, closer to S. Does it make sense to you? So you're saying indicate clearly the region in which X must lie within the square. So it is within the square. Okay. So that is one. So it could be here also. Okay. Within the square. Now let's look into the next condition. So let me underline what is this orange thing. Yeah, we did. dx is greater than equal to bx. So from D, the point is farther away as compared to point B. So we'll draw this line now. And so it is could be on this side. Is that okay? Somewhere here. That is the second condition. And the third condition for us is, it says OX, center is, oh, I forgot to write that. OX is greater than A. Greater than A means it is like a way out of the circle. Do you see that? Out of the circle. So looking into all these conditions, greater than equal to, when you combine all these conditions, what do you get? Right. Let me highlight that portion, correct? So that is the portion which we get. And this time the edge of the circle is included. So that is how you have to do it, right? So this is what it is. So everything in that sector is your answer. So I hope that makes sense, and that is how we are going to shade regions. And now we'll take up examples where the construction will be involved, and we'll decide on this basis what is the indicated region. I hope that makes sense. Thank you. Now I have taken up a question which will need a bit of construction. Well, the question here is, ABCD is a square of side 4 centimeters. A variable point P moves inside the square so that PA is less than equal to 4 centimeters. PC is less than equals to PA, and the area of triangle ABP is less than equal to 6 centimeters square. Construct ABCD accurately and shade the region in which P must lie. So what we have done here is actually already constructed this square. So this part I kind of ignored. We'll concentrate on shading the region, right? Okay. So the two conditions given to us are, the first one here is that PA is less than equal to 4 centimeters. That means the point is, or we can actually draw an arc from A 4 centimeter long. Let's assume these are accurate, right, enough to do the work. So I'm just measuring this, and we'll put it on A and draw the arc, right? So it should actually go from B to D, right? So let's see. So let me adjust it a bit. Okay, so it's almost there. So we could draw this arc. We are saying that the point is, I know the square is not very accurate. Anyway, so that is how it is. So basically, in the first condition, what we are saying is that the point is 4 centimeters. That means it could be on this arc or somewhere in this area, correct? Assume that this joins point D. Okay. The second condition given to us here is that PC is less than equals to PA. That means the point is away from A, closer to C, right? So this we could get by joining the diagonal. So let me join the diagonal now. Okay, so the accuracy is not there, but I hope you understand the method. Okay, so this is the diagonal. And when we say that PC, that means point P is closer to C than A, that means we are looking for somewhere here. Now that is the common portion. So I'm not highlighting the one which is not to be considered. Okay. So now we are converging to this particular sector. Okay. The next condition here is that the area of the triangle is less than 6 centimeter square. So P is so that the area of triangle ABP is 6 centimeters square. Now what is area? Area is half base times height. Correct? So base is 4 centimeters. Since we are looking for this to be the base, we know this is 4 centimeters. So it is half of 4 times height. We don't know what it is. However, it should give us a value of 6. That is what it means. So that means height is equals to 6 and that reduces to 2. And 6 divided by 2 is 3 centimeters. So we are looking for a height of 3 centimeters for the triangle whose base is AB, right? So we are saying base is AB and height is 3 centimeters. So what we can do is we can mark 3 centimeters and draw a region within that. Correct? That should give us the answer. So let's take 3 centimeters from A, which is here, and mark here also 3 centimeters. The line joining this. So point P could be on this line since it is less than equal to. So anywhere on this line point could be, or it could also be somewhere there, right? Now since we have already converged to that portion, we are now looking for the point in this particular portion. Do you get an idea, right? So that becomes the solution. Correct? So here we have 3 units away from A. Let's call this point as EF. So the region which can be highlighted is, we have to include the lines also. Correct? So that is your solution. Is that clear? Right? So when you construct your square, it has to be very accurate. I kind of approximately sketched it. The idea is to understand how to shade the region. So my focus is on this point. I hope that's clear. Now we have understood what it means to shade region in which a point P must lie. So let us now solve this particular question, which is construct triangle ABC in which AB is 5 centimeters, angle BAC is 45 degrees, angle ABC is 60 degrees. Construct also the perpendicular bisector of AB and a circle center C, radius 4 centimeters. If a point moves inside ABC so that PC is less than 4 centimeters and PA is less than PB, shade the region in which P must lie. So let's begin by constructing the base AB first, which is 5 centimeters. So let us say we have this base 5 centimeters here. Correct. So that is AB for us. Now we have to construct an angle of 45 degrees at A and 60 degrees at B. Okay, so let's do 60 degrees at B, which is we have to just make an arc and with the same radius cut it, right? So that is 60 degrees. So if I join this, what we get here is an angle of 60 degrees, right? So that's it. Okay. Now on the other side, we'll make angle of 45 degrees. Now to make 45 degrees, what should we do? Well, let's make 90 and then bisect it, right? So here we'll make an arc like we did earlier and then cut it twice. That means 60 and again 60, right? And then we are looking for in between to get 90, right? So in between we'll get 90 degrees. (60 plus 30 is 90, so we kind of bisected it. So that is 90 degrees. So we'll draw this 90 degrees and then create another line which will give us 45, correct? So that is perpendicular at A and now we will do bisector of this particular angle to get 45 degrees. So we already have 2 points here. We can actually open the arc longer than half of it, place it on these points and cut it across. So with that we get 45 degrees. Let's join. So that becomes the triangle ABC for us. So let me write down C for this point. So we've done the first part. Now construct also a perpendicular bisector of AB and a circle's center C, radius 4. So let's now make perpendicular bisector for AB. So perpendicular bisector means you open the radius of the compass slightly more than half, right? Okay, and then mark arc. So that should be a bit longer, but anyway, we'll try to manage it. Yeah. So yeah. That's it. So we get a perpendicular bisector here. Okay. Now from point C, we have to draw a circle with radius of R units, 4 units, okay, 4 centimeters. So that will run into my typed area anyway. So 4 centimeters, let me open this to 4 centimeters. It is almost 4 here. Okay, there we go. So from here, I'll make a circle of 4 centimeters. This is 4 centimeters with circle center at C. Now let's look into the conditions and mark the region. So we got all these things, right? Now the condition is if a point moves inside ABC, that means within that triangle, so that PC is less than 4 centimeters. So the point distance from C is less than 4 centimeters. So it is within this region. PA is less than PB, so the point is closer to A than to B. That means the point is on this side. So the first condition was if the point moves inside ABC so that the point's distance from C is less than 4, so not including on the circle. And the second condition is that it is closer to A than to B, so it becomes this portion. Do you see that? And it has to be within ABC, right? So it is within ABC, the triangle, and it's closer to this. So we'll basically take this side as a dotted side. So we'll use this as a dotted line since it is less than, and shade the portion which is right there. I hope that makes sense, right? It is inside the triangle ABC, correct? So that makes all the things together. The point moves inside the triangle. So we are not using this line also. So like we are using this as the dotted portion, correct? So that becomes the shaded region for the given condition. So I hope it makes sense, right? So that becomes the shaded region which we are looking for. So I'll name this point will be D for us, that will be E for us. And let this be the midpoint M for us. So that is the shaded region, which is the answer. So I hope you enjoyed this learning process of loci and construction. We began with a very simple example to identify the region. Then we took up example for circle and square. And this time we constructed triangle with circle and different angles and angle bisectors. So I hope that gives you good practice. So the idea here is to teach you method of doing. My diagrams may not be that accurate at times. You lose some accuracy. Perfect. So pardon me for that, but I hope the concept is clear. Feel free to write your comments, share your views, and if you like and subscribe my videos, that'd be great for me. Thanks a lot for watching and all the best.